Welcome to the ET-335 Midterm Practice 1. Okay, let's do our first problem here. This is a debounce switch and it is using NORs. So that means it's an active high and that means our input should be a high. So we're going to put VCC on here. That's it. Okay, and we're going to use pull down resistors. And pull down resistors. Okay, so this is an accurate. If it were NAND gates, we would be using a low input in pull-up resistors. Here's the CAD answer for our debounce switch. And if these were NAND gates, this would be a ground and these two would be pull-up resistors. So this is an active high and it requires pull-down resistors. Okay, let's demorganize this circuit. So the first thing I would do is change this sign to multiplication, break our bar, and that means these two are going to cancel out. So we're going to have A, B, C, D plus E, and we could break that again. So we have A, B, C, D times E, separate bar, and we could break that down again to A plus B plus C plus D need a parentheses there times E bar. So let's go ahead and draw our circuit. So we're going to have a bubbled input OR. And we're going to have bubbles on all these. A, B, C, D. And we're going to multiply times E. And he has a bubble. And it's a plain O. Good. Here are our answers for our De Morgan problem, and we can stop at this stage here, end up with a 4 bubbled input NAND, or we can go ahead and do one more stage and end up with a 4 bubbled input OR. Here we have a new Cardinal Map. This one would be a product of the sums where we're going to evaluate out as a 0. So we're going to have a 0, 0, 0, 0, 0. So that's going to be here. Then we have a 0, 1, 0, 0, which is going to be here. And then we have a 0, 0, 1, 0, which is going to be here. And then we have a 0, 1, 1, 0. Okay, 0, 1, 1, 0, which is going to be here. And we have a 1, 1, 1, 1, which is here. These four are going to drop. We're going to evaluate out the numbers. So we have, looks like A sticking, B's a goner, C is gone, and we have a D, and that's a plus. And then we're going to multiply it by the remaining in that box. So we have A plus B plus C plus D. bar, 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 bar. Good. There's our beautiful CAD drawing, and it looks like we got the right answer. Here we have a decoder, and I did not specify what kind of gates to use. So we want a syncing output, so why don't we just use a NAND? And we're going to have a 1, 1, 0, which is what we're asking for. So let's put our LED, and we're going to need VCC in order to drive it. So we're going to have 1, so let's just go ahead and why don't we use these, why don't we use C and D, excuse me, A and C, and we could tie him here. And then we have another. All right, so let's put a NAND here. So we're going to get a 0 out. Many different ways we could do this. So we're going to get a 0. And now we have 2 zeros. And we need a 1. So that is going to be a NOR. So let's check. We got 1, 1, 1, 1, 1, 0, 0, 0 is a 1, and our circuit will work. Okay, here we have our CAD drawing of our decoder, and it looks like we did pretty good.